Right, good day everyone. Carrying on with Matric Corona Maths. And just to remind you from yesterday, remember you're always going to use the rule, unless they specify use from first principles, then you're going to use the limit as h tends to naught, etc., etc. Okay, but otherwise you're going to always use the shortcuts. Okay, and remember the different notations. This is an instruction. This means go differentiate with respect to x. What do you have to differentiate? Ax to the n. What does the rule say? You times those two together, so you get na. What do you do to the exponent? You take away 1, so it becomes x to the n minus 1. Just one thing I didn't mention yesterday, this is also a form of instruction, d dx. So differentiate with respect to x. D means tiny change. Ax to the n will be nax to the n minus 1. So that's your fundamental rule. Okay. Then the second thing we talked about is that you cannot differentiate an expression with a variable in the denominator. Okay. And how do you get rid of that? Well, you use your rule that 1 over x to the m is equal to x to the negative m. In other words, if you move a power within a single term, if you move a power up, okay, the sign of the exponent changes. So just to get your head back into it, give this one a go. Y is equal to 4 over x squared minus 1 over x to the negative 3. Give that a try. And right. So if I try that, I've got a problem because I've got a variable in the denominator. So I've got to get what I call it in what we call it in differentiable form. So it's still just y, and it'll be y is equal to 4x to the negative 2 minus, I move the power up, the sign of the exponent changes. I move the power up, the sign of the exponent changes. So it'll be minus x to the positive 3. Now the variables are in the numerator, the top numerator, so I can differentiate. So I get therefore, my notation changes. Now I'm finding I've got the derivative, dy dx is going to be differentiating y with respect to x will be negative 8 times those two together, minus 1 from the exponent, so it'll be minus 3. 3 times negative 1 is negative 3. X 3 minus 1 is 2. So you can leave it like that. If the question said write it with positive exponents, then you'd have to write it as minus 8 over x cubed. But if it doesn't specify that, you can leave it in that form. Right, so the new word for today. First of all, a little conversation about surds. Surds are things, those kind of signs. Okay. And if you recall from grade 3, okay, that surds can always be written in exponential form. How do I write them in exponential form? Well, x to the m root n can be expressed as a power x to the m over n. That bit over there goes to the top, that bit over there goes to the bottom. So, go try to those two, write those in exponential form and put the variable in the numerator. Okay? Give those a try. So square root of x, well it's implicit in this situation that x is x to the 1 and square root means 2 there. So I'd rewrite that as, in exponential form, as x to the power of a half, right? Then 1 over x squared cube rooted, well first I'd get it in exponential form, so it becomes 1 over x to the 2 over 3. If I was differentiating, I'd then have to move that up and it would become x to the negative 2 over 3. Now it's in differentiable form. Okay? And why are we doing this? Well, not for fun, because the reason why we need it is you cannot differentiate, okay, if you have variables, okay, in surd form. So you're always going to have to get rid of two things. You're going to have to get rid of variable in the denominator, and you're going to have to get rid of surds, and then we can try and go ahead and differentiate. Right, I've had complaints that you don't have time to get things down or whatever. So there you go. Press pause, copy down what you haven't got. Right, we are back. Right, so just remember please that the key idea is that you cannot differentiate between the rules if there are variables in the denominator and if there are surds in the expression. So in other words, x to the m, and we use this rule to overcome that, x to the m root n, get it in exponential form, will be equal to x to the m over n. Right. So in a question like this, in example 1, it says go differentiate. Remember, that's an instruction. Differentiate with respect to x. That whole thing over there. Well, the problem is, okay, we've got a third there and we've got a third over there. Okay. Now, even though that is in differentiable form, okay, we can't do any differentiating yet because the whole expression has to be in differentiable form. You can't just differentiate half of it, okay, and not carry over the rest. So, we're going to say, right, I've still got to differentiate. I haven't done that instruction yet. So I'm going to keep 5x squared, 3 root x. Well, the 3 doesn't get affected, but root x is going to be x to the 1 over 2. And then over here, I'm going to have minus 2 over minus 2 over x, sorry about that. My wife is calling. Minus 2x to the third. Okay, and skip our steps with practice. So I've got to find the derivative of 5x squared, okay, plus 3x to the half minus 2x to the negative third. You can skip out steps, okay, as long as you get to that over there. Okay, so 5x squared plus 3x to the half minus 2x to the negative third. Okay, and if I go differentiate that, I get 10x, okay, 2 times 5 minus 1, 3 over 2, 3 times a half is 3 over 2, x to the, well, a half minus 1 is a half minus 2 over 2, which is negative a half, minus a third times minus 2 will be positive 2 over 3, and then x to the negative a third minus 1 is negative 4 over 3. So there's your answer. 10x plus 3 over 2 x to the negative a half plus 2 over 3 x to the negative 4 over 3. I'm going to pause for a bit and make that call before I get into big trouble. We're back now. Right. So I want you to give this one a try. Okay. It says, let's get the other one down first if you haven't got it down. Differentiate with respect to x. Okay, you've got x to the 4 root 5 plus x to the 2 over x to the 9 plus px minus 5. It's important that it says with respect to x in this case. Okay, the other way they would have asked you is find d dx, okay, or dy dx. Right, so give that a go. So the first problem is we've got surds with variables in the denominator, so the whole thing is not in differentiable form. So you're going to have y is equal to, okay, x to the, we can see the bottom corner, x to the 4 over 5, x squared over x to the 9, you subtract the exponents, it's going to be x to the negative 7, plus bx minus 5. So now it is in differentiable form. Okay, and I end up with, okay, dy dx, okay, is going to be equal to 4 over 5 x to the negative a fifth, okay, 4 over 5 plus 1 is 4 over 5 x to the negative fifth, minus 7 x to the negative 8. Now the derivative of px, p behaves like a constant, so that's just p, and the derivative of negative 5 is 0. The derivative of constant is 0. So I get x to the 4 over 5 plus x to the negative 7 plus px minus 5, and there is my solution over there. Right. The next one, okay, always idea is that you always have to simplify first before you differentiate it. So here it says go find the derivative of that whole thing. Okay, you can't go differentiate those individually. If you did that individually, you'd get an answer of, okay, the derivative of 2x minus 3 would be 2, and the derivative of x plus 1 would be 1, so you get 2 times 1, which is 2. Okay, what you have to do is simplify it first. This is an instruction. d dx means go differentiate that. So I haven't carried out the instruction, so I leave it there. I get d dx, and I get 2x squared plus 2x. 2x minus 3x is going to be minus x. 2x squared minus x minus 3. Okay, and if I differentiate that now, okay, I'm going to get the derivative of 2x is 2x squared is 4x. 2 times 2 is 4x minus 1. The derivative of negative x is negative 1. And the derivative of a constant is 0. Okay, so try that one. Okay, it says differentiate f of x is equal to 2x minus 5 squared. Give it a go on your own. So I still haven't differentiated, so it's still f of x, and that's going to be 4x squared times them together minus 10x times by 2 is minus 20x minus 5 squared is plus 25. Now I can go differentiate. So now because of differentiating, I'm going to write f dash x, and that'll be 4 times 2 is 8x. Derivative of negative 20x is linear, gradient is negative 20, and the derivative of a horizontal line is 0. So there is your solution. Right, sorry if I seemed a bit distracted. There are all kinds of things going on. Phone calls, people. My goodness. Just make sure you've got all of that down, please. Okay, I don't know if I gave you time to get that down. Okay, and if I spotted any errors and you point them out to me, they were done on purpose. And first one to let me know, Morgan will buy a chocolate. Thanks, Morgan. Right, back. So carrying on. Okay, that is all right, scum. Right, division. Okay, so guys, if you're differentiating and you've got division with variables in the denominator, well, they're kind of two types. And the first type is if there is a single term in the denominator. Okay, so say I gave you 7 plus 14 over 7. Well, what most of you would do is you'd say, well, 7 plus 14 la-di-da is 21, and 21 divided by 7, which is perfectly correct, which is 3. However, you could also do this by saying 7 plus 14 over 7, okay, is the same thing as having, it's all divided by 7. So it's 7 divided by 7 plus 14 divided by 7, which is equal to 1 plus 2, which is 3. And that's a technique we're going to use when there is a single term in the denominator. Okay, there are other things you can do, but that's the easiest way to think about it when there is a single term in the denominator. What you can't do is cross-cancel and say 7 cross-cancel 7, and you get 14. Remember, if you do that, you kill a small baby elephant, which is not very nice of you to do. Right, next one. Find the gradient at x is equal to 1 on this curve, blah, blah, blah. Right, y is equal to 5x cubed plus 3x squared minus x plus 1 over x squared. Well, I've got a variable in the denominator, so that's a problem. So I first got to get it into differentiable form. It's a single term, so what this means is you've got y is equal to, what's the thing recording? Yeah, it is. Y is equal to 5x cubed over x squared plus 3x squared over x squared minus x. You can skip out the step if you get used to it. Just be careful, don't cross cancel though. Remember the elephant, plus 1 over x squared. Right, now you simplify each, still not differentiable because you've got a variable in the denominator. So I want you to go simplify each individual term so that you have no variables in the denominator, and then I want you to go and differentiate that. Right, give it a go. So I end up with y is equal to 5x plus 3 minus x to the negative 1 plus x to the negative 2. Okay, that is now in differentiable form. So I end up with dy dx, okay, is equal to, well, the derivative of 5x, the gradient is 5, okay, plus 3, the gradient is 0. Here, negative 1 times negative 1 is plus. Okay, take away 1, it will be x to the negative 2. Here, negative times a positive is negative 2. X to the take away 1, negative 3. So I end up with that over there, which you could write, you could leave it like that, but they want us to find the gradient at x is equal to 1. So some of you will be more comfortable if you just rewrite it with positive exponents. You don't have to, you can just put it into your calculator if you want, but that means plus 1 over x squared. You should be comfortable with that. X to the negative 2 becomes 1 over x squared. Minus 2x to the negative 3, if I want that with positive exponents, it becomes minus 2. That stays there. The x to the negative 3, you should be able to do this technique. Sometimes they say to you, leave the answer with positive exponents, and then you have to write your final answer like that. That negative 2 doesn't get affected. The negative 3 is only on the x. So when I move a power up or down, the sign of the exponent changes. So that is your derivative equation for this particular function. But the question says, go find the gradient on the curve at x is equal to 1. So to find the gradient at a point on the curve, we sub into the derivative equation. So the gradient is going to be, I replace every x with 1, and I get 5 plus 1 over 1 squared, replace the x with 1, minus 2 over 1 cubed, which is going to be 5 plus 1 minus 2, which is 6 minus 2, which is equal to 4. Gives us a nice number. Okay. Good there. Right, carrying on. So, we had division by one term, in which case you just divide it out, okay, and then you differentiate it. But sometimes you're asked to differentiate it, and there is division by more than one term, okay, in the denominator. I should have put, okay, if there's more than one term in the denominator, and you're asked to differentiate, then what you're going to do, it's very similar to limits in some ways, because a derivative is a limit, okay, is you're going to factorize, cancel, and then differentiate. Just like you did with limits. Okay, you factorize, cancel, okay, and then you find the limit. Okay, so I want you to try this question using that logic. Try and apply it. Find the gradient of the tangent to f of x is equal to x squared minus 5x plus 6 over x minus 2 at x is equal to 3. So, give that a go. So, it's not differentiable. Okay. And we can't move that up because there's more than one term. We can't divide individually like we did last time. Okay, so our only option is really to try and factorize first. Okay, so we're going to say, right, x squared minus 5x plus 6 factorizes 2, x minus 3, x minus 2. Check it, always be careful, x squared minus 5x, blah, blah, blah. Okay, plus over x minus 2. Okay, you can cancel. Just one thing to look, which is good math, is you say, well, f of x then is equal to x minus 3, but you should, if you cancel the variable, state that x cannot be equal to 2, because otherwise the whole original expression, if x was 2, would be undefined. So that's good math to put that in over there with that statement as soon as you cancel the variable. Okay, so that's f of x, and now, so I've factorized, I've cancelled, now I can differentiate. So f dash x is going to be, well, the derivative of x is simply equal to 1, and the derivative of the constant is 0. So there is your answer over there. Right, last example. Okay, differentiate 2x cubed plus x squared minus 2x minus 1 over 1 minus x. Right, so you've got more than one term in the denominator, so somehow you're going to have to factorize that and cancel and then differentiate. Well, the only way you can factorize this, if you remember from whenever, grade 10, is to pair up. I haven't differentiated yet, so the instruction stays the same, it's still there. If I pair up and take out from these two, I can take out x squared as a common factor. To get back to that term, I've got to times by 2x. To get back to that term, I've got to times by 1. So I get x squared, 2x plus 1. Okay. I've made a mistake in this question. I'll show you why now. It's a deliberate mistake. Okay. If I take out a negative, okay. No, I haven't. No, I haven't. Oh, amazing. Okay, so x squared 2x plus 1. If I take out a negative, I'm left with 2x plus 1. Differentiate, if factorizing by pairing is going to work, your brackets have to be the same. Okay, so I've got x squared 2x plus 1 minus, over brackets, 2x plus 1 over 1 minus x. Right. Now what you do is you've got two terms, okay, and if you've got two terms, okay, what you've got to do is you've got to take out the common factor. I haven't differentiated yet, so I'll still leave this notation. What's the common factor between those two terms? It's 2x plus 1 is a common bracket, if you want to think of it like that. The 2x plus 1 there, the 2x plus 1 there. What I have to times 2x plus 1 by to get back to that squared, to that term? X squared. What I have to times 2x plus 1 by to get back to itself? Well, by negative 1. Check you're comfortable with that. I've taken out 2x plus 1 as a common factor to get back to there, times by x squared to get back to there by negative 1 over 1 minus x. I still can't cancel because I can still factorize that more. Right, so go try to finish that off for me. Okay. Go factorize that, change signs, cancel. Okay. So I get the derivative, give it a try, of 2x plus 1, x minus 1, x plus 1. Okay. Now, I want to cancel and I've got 1 minus x here. So how do I overcome that problem? I take out a negative from the denominator to get back to where I started. That'll be negative x plus 1. I'll take out the negative. Now, I can go cancel. So I'm going to be left with the derivative, the x minus 1's cancel, of negative, I've still got that negative over there, just putting it up here, negative 2x plus 1, those are cancelled, times x plus 1, okay, which is going to be, I still haven't differentiated, I should write here what, okay, that I've got rid of that, I should write x cannot be 1, okay, and I get the derivative of 2x times x is negative 2x squared times by the negative. I get 2x plus x, which is 3x, times by negative is negative 3x. 1 times 1 is 1, times by negative is negative 1. Now, at last, I can differentiate, and I get an answer of, just seen something now. Derivative of negative 2x squared minus 3x minus 1 is going to be negative 4x minus 3. Right. Hopefully you noticed in my exhausted state that I didn't fully answer that question over there. Okay? Because the question was find the gradient at x is equal to 3. Okay? Well, if I've got f dash of x is equal to 1, okay, squared minus 5, yeah, I did that all right. Okay, then the gradient everywhere on the curve, including at x is equal to 3, is 1. Okay, bit of a layout question. Okay, guys. Right, the last thing I want you to do is just quickly read through the examples that's similar to what we did, but not the same, of your mind or math, page 221 to 225. Then go back to exercise 4, okay, and page 226, and it was number 1 to 14. Just check on the WhatsApp that I sent you. I'm not entirely sure if I wrote that down correctly. And I want you to do that, and remember it's posted. And have a fantastic evening. And we have what? I don't know. Nearly lockdown coming in, lockdown. Be strong, be good, have fun. Bye.